So dear students, this is the end of our section voltage converter and breadboard interface. In this section we have learned how to create our first PCB. That is done by, first of all, let's launch KiCad, double click on it, and we have created our project by going to file and new project, and we created the first project. But as we have completed our project in this section, so let me open the already made project. Open project. I have placed the project file on the desktop. This was the project file. Double click on it and open the project. When I double clicked on that, we have created a PCB and a schematic file. We have also seen how to create Gerber files. So the first thing we have done is that we have drawn our schematic. So in order to draw a schematic, we use schematic editor. In the schematic editor, what we do, that on the drawing sheet we have placed the symbols of our component. By going to add symbols, click over here. This will open up the symbol library. This is the symbol library where you can choose any of the components. Like we have these are all the symbols of the component. You can simply double click or hit OK to choose them. So we have placed these symbols of regulator, capacitor, resistor, and all these components you are seeing over here from the symbol library. To leave any tool, hit escape, and I have leave the add symbol tool. After we have added the symbol, we have drawn wires between them by using the add wire tool. This is the add wire tool which you can use to add wires between the component. Hit escape. After we have added wire, we have associated footprint with each of the component. Like, let me show you. Select over here, hit E, and this is the footprint I have selected for this component from the footprint library. Click over here, and this is the footprint library which from where I have selected the component. Let me close this. After we have placed the symbol, associated footprint, made a connection between the footprints, and we have given names to this. We have seen in the previous video how to annotate our schematic. After that, we have performed an electrical rule check by opening electrical rule checker, running ERC, no errors and no warning. After that, we have moved toward the PCB editor. We have opened the PCB editor. It's taking a little time to open. This is the PCB editor. We have created this PCB in this section. So when we move from schematic to PCB, we have seen that we have already associated footprint with the components, and we have seen that all the footprints were present on the PCB editor. Then what we do is we choose the edge cut layer and draw the boundaries of our PCB. After drawing the boundaries of PCB, we placed our component. Like, firstly, our main requirement was that J101 and 103 should be 47.6 mm apart. We first of all draw a measurement tool using this measurement add aligned linear, this tool to align our connectors in a straight line at a distance of 47.6 mm apart. After that, we have placed all the components at our desired location, and we have kept in our mind that there should be least intermingling of the tracks, that we can easily connect our components using the tracks. We should least amount of vias and least amount of layers for designing our PCB. So after placing our components, we have drawn tracks between the components. We have created two fill zones, front copper fill zone and bottom copper fill zone, and connected them with the top and bottom fill zone with the help of these vias, as well as they are also connected with the help of these connector ground pins, because they are through hole. They travel from top to bottom of the PCB. After this, we have arranged this reference designator of all the components and added a logo of the KiCad and text of the KiCad, a voltage converter for breadboard over here, added few text over here like this 5 volt and 3 volt over here. And you can also see that all the text we have added in front seal screen. This is the front seal screen we are now looking at. After we have done all these things, then we performed our design rule check over here. And when we performed a design rule check over here, we got lot of errors. That error was very beneficial because we have learned how to remove this error, and while removing errors we learned a new things. So we have removed these all errors, and now then we created Gerber file for sending to the manufacturer. And for creating that, go to plot, and we created our Gerber file in our Gerber directory. As well as apart from Gerber files, we also need drill files. So click over here, generated drill file. We generated Gerber x2 and click generate drill files, and we found that we have created two drill files. Hit close. So after doing this, all this as a last check on the what we have designed, what we did is we went to our main interface of our KiCad and launched Gerber viewer. In the Gerber viewer, we opened all the Gerber files that we have created for last inspection. So for that we have selected all these files, and let me unselect this Gerber Java file and hit open. And now we viewed all the files over here. After that we have cleared all layers. Then we have also seen Gerber our PCB Gerber job file. So this was that job file we have seen. Now our first project, our first PCB is complete. You can send this to the manufacturer for manufacturing. One thing more, we have seen this in our 3D viewer. Let's check it how this looks in our 3D viewer. Here few of the settings we have seen that, like this is for you can zoom in, zoom out. You can fit your sheet again. This is for rotation. From here you can flip. From here you can move your PCB left, right, top, bottom. Here you have seen the components, how your PCB actually looks. So this is our PCB. After we manufacture it, stuff all the component on it, your PCB will look like this. So hope you have found this section very helpful. I am working more on the KiCad, and I will be adding more information in this course. In the coming sections we will be learning about how to make your custom symbols and custom footprints. So see you in the next section, see you in the next videos. Thanks for joining me. Thanks for being a part of this course.